LED car lamps. Interior ones, I assume. This is a festoon, I believe they call it, which has a couple of ends on and just plugs in somehow. And then there's another one here which is designed to look, I assume, like a normal torch bulb. 2 pins on the end and then the contact at this end. So there's a contact at that end and then the case is another contact. And the third type I've got are these, which are double-sided, and it says, if we have a close-up, if we look at it close-up, then it has an R1 here which I've removed because on the other side it says it's CAN bus, and CAN bus needs its bulbs to use a certain amount of current or it assumes they're broken. So they've had to put a couple of resistors on to put a dummy load on so CAN bus doesn't flash up and say the bulb's broken when it isn't. Fascinating things. This one's fascinating because we have a 1, 2, 3, 4, 5, 6, 7, 8, 9 LEDs on that side, 9 LEDs on that side, but 4 resistors. 18 LEDs, 4 resistors. How on earth does that work? What I was surprised to start with is that these are all connected. They're all joined, even though they look to be separate. They all connect together for some reason I don't understand. If we want to test one of these things then, I've set up a meter here with a voltage on it, and the meter here is measuring current. Wrong way round, but that doesn't really matter. I've got this one set up, so we'll have a look at that first. Hopefully it's set up. Let's try increasing the voltage. And if we increase the voltage, then we can see the LEDs have lit up on both sides, apart from, this is probably the reason I've got it, seem to be 2 LEDs there that aren't working. I've got 7.6 volts, so let's try taking it up to 12. No, I won't take it up to 12 because it isn't going to be able to stand 12 volts, I wouldn't think. If it's got 2 LEDs down, it's going to blow the other LEDs, I would think. One of the disadvantages of this sort of circuit. So how have they done it? How have they got 4 resistors for 18 LEDs? Let's disconnect that and have a look at the circuit. So when I looked at the circuit, I was quite surprised in what I found. Each side is different. That was a blow. I would have thought if you're going to design something, design it the same both sides, but no, they're too cunning for that. So they've designed each side differently. Can we see that? Yeah. So if we look at one side, goodness knows which is which, but let's suppose we look at this. We've got all the contacts connect together, then we have the 2 resistors, and the interesting thing is that resistor 1 isn't used on this side. Resistor 2 is. The power goes into the top of resistor 3 I've called it, goes through resistor 3, and then into the 3 LEDs here. The other side of the LEDs then comes round and goes into these 3 LEDs, and the output from those 3 LEDs goes to the bottom 3 LEDs, and they then go back to 0 volts. They've drawn it as a circuit diagram here. So the positive comes in through the two resistors, which are actually in parallel. So R3, which is what we use in here, is in parallel with R4. So R4 isn't used on this side, and R1 isn't used on this side. It just goes straight past it. And then that goes to 3 LEDs, which then go through, and then go through 3 more LEDs, and then 3 more LEDs, and then out to 0 volts. So if one of these LEDs is not working, then that means all the current is going through these other 2 LEDs, which will be overworked, and therefore they're going to blow. The bottom circuit is the opposite of the top one. We have the 0 volts then, R1 and R2. So R2 and R1 are used. Remember, this is upside down, so when we turn it over, R1 becomes behind R2. It goes through R2 and R1, and then to the 0 volt side of the LEDs, round through these LEDs, round there, through these LEDs, round back, and back through these LEDs. Absolutely brilliant circuit. I love that. Discovering how that word, well, made my day. Perhaps we ought to look at another one. Let's look at one of these. These then are designed to be like normal glass filament bulbs with an end on. It's been squashed, which is why I've got it. And this then is a similar sort of thing, in as much as we've got sets of 3 LEDs fed by a resistor. So we have a 330 ohm resistor feeding our 3 LEDs, which then presumably come back to the bottom. There's 8 sets of LEDs, 1, 2, 3, 4, 5, 6, 7, 8 sets of LEDs. The bottom is interesting. The solder blob at the bottom just connects on to one side, which looks very similar to the last lot. It says it's CAN bus, but I haven't worked out the currents, but I find that interesting that they should put that on. There's no big resistor between the two. Fascinating. Just heat this up. It's just soldered onto one side, and then there's just a little wire in the bottom coming out down to the bottom to make it like a push-in bulb. Fascinating things, absolutely brilliant. If we were to connect this up, shall we try? Connect positive to positive. I've marked it as red because these have to go in the right way round, like the previous ones. If you put them in the wrong way round, they don't work. So I put that in the right way round. Let's try a bit of power. Give me the power. Yeah, power, man. So there we've got the power. And there we can see that in fact all these LEDs are working. If we zoom out, you can see at 7 volts I've only got 1.5 milliamps, but if I take it up, now these should go up to 14 volts because an alternator on the car is going to produce 14 volts, but I don't want to go up that high. I've got 99 milliamps going through it. That's about 12 milliamps, is it? 12 eighths and 96 are they? So that's only about 12 milliamps going through each set of 3 diodes. So, nice little job. Probably if I put it up to 14 it'd take a lot more, but I'm not going to do that because I don't see any point in it. I don't see any point in it at all. Why am I doing it? Just a bit of fun. I like doing it. I love playing with them. Right, let's disconnect that one. And let's look at the last one. The last one then is, I believe, called Festoon bulbs. If we do a close-up, we can see it's got 8 LEDs on it. That one looks like it's probably damaged. Don't know if these should have been inside something or if they just come like that, but they've obviously been damaged at the ends. To take the ends off then, there's just some solder, so I just heated up the ends as hot as I could get them to get the ends off, and they seem to come off reasonably well. So if we look here, we've got the wrong side. Let's try this side. We can see a bit of the circuit boards come off there. There's a bit of solder left here, so the end just went over. Oops, I've lost it there. That just went over there and soldered on at that end. Similarly at the other end, it just went on at the other end there. It's got a lovely heat sink on it, and it's got a 75 ohm resistor for the LEDs, but what it did have that I've removed is a CAN bus, I assume, resistor. So on this one we can see there's a 101 or 100 ohm resistor, and that goes across the power in to make sure it looks like it's got a load for CAN bus. Couldn't work the circuit out, wasn't clever enough, so I actually took all the components off, cleaned the board up to work out how the circuit worked. Essentially this end then comes through somehow to one of the in terminals, so we have one of the in terminals there connected from this end, and then the other in terminal comes from this end here. As a beautiful little, has this one got one on? Yeah, this beautiful little diode bridge. So this is different than the other ones because the diode bridge sorts out the polarity. It doesn't matter which way around you put it in, it always lights. Brilliant. Really nice little thing. Love it. If we look at its circuit diagram, well, the layout confused me because it bobs through from one side to the other. So we have the in here and here, and of course this is an upside down version of that, so this connects to this orange here, and that's where the 101 load resistor is. The output from our diode bridge then, positive bobs underneath and goes all the way to the other end underneath the board, bobbing up here to go through the 75 ohm resistor. So this then feeds these LEDs, which then go on to this blue area, which then feed these bottom 4 LEDs, which then just go back to the negative of the diode bridge. So here we have it a little bit simpler. We've got our 100 ohm across the input, our diode bridge with positive coming out, going through the 750, down through the LEDs, and then down through the second set of LEDs, and then back to the 0 volts. Fascinating thing. Really liked it. Really enjoyed playing with it. Don't know what I'm going to do with it though. What am I going to do with something like that? Must be able to find something I can do with it. Put it in a cupboard probably and forget about it. Let's try connecting this one then. That's connected that. Got lots of little bits as well off surface mounted components which I'm sure I can use, especially that little diode bridge which is beautiful. Just have to work out what current it can take. I can't imagine it can take very much, although this takes quite a bit of current. Let's try plugging in, and can't really see anything at that. Is it not working? Oh, there we go. So it looks alright. There's no point turning it over because there's nothing on the other side. And what sort of current is it going to take if I boost it up to 12 volts? Wow. 12 volts, 65 milliamps, so 65 divided by 4, 16. So once again you've sort of got 16 milliamps going through each of the LED pairs, as it were. Lovely little thing. Nice. Like it. So, what to do with them? I've enjoyed playing with them. I've enjoyed getting them to work. Does begin to feel a bit warm. Suppose we could calculate out the watts. If I could multiply 12 by 65. Well, 12 times 10 would be 120. And 6 times 120. 720 milliwatts, maybe a bit more. So maybe it's about 1 watt at 14 volts. Definitely getting warm is that resistor on the end, which is strange because that, I don't think that's, get rid of it. Yeah, that's not really near the heatsink. Strange. The heatsink itself had a tiny bit of gunge on the back for the circuit board. But yeah, that 75 ohm resistor isn't near the heatsink, and that's what's getting warm. I could do a calculation on that, couldn't I? Yeah, I could, but never mind. Been a really interesting project. Really liked it, really like these things. And it's just a pity that these have got some dead LEDs on them. Maybe I kill them. I'm good at killing LEDs. Anyway, bye now. Bye.